Hey y'all, so I just wanted to jump on really quickly and make you a video of numbers 17 and 18 in your section 3.1 part 2 homework. Now, these are just graphing rational functions. We did a few of these examples in class, but I thought it would be helpful for you, one, to have a few more examples via video, but also to be able to see me using the actual graphing tool in a video. So hopefully you find this helpful. Again, we'll do 17 and 18. So we'll go ahead and get started with number 17. Okay, so 17 says graph the function, plot all necessary asymptotes. For vertical asymptotes, make sure there are at least 2 points on each side. Use the plot point tool for non-integer coordinates if necessary. Quite frankly, I use the plot point tool for everything, so it just makes plotting points easier and less room for error. But let's go ahead and take a look at our function right here, which is m of x. So m of x equals 5x plus 1 over 2x minus 5. Now, when you graph rational functions in ALEKS, the first thing you want to do is graph all of your asymptotes. So we'll go ahead and take a look at our vertical asymptotes first. So we know that vertical asymptotes come from taking the factors in the denominator that do not cancel and setting them equal to 0. Well, if we look at the numerator of this function, 5x plus 1, it doesn't factor. And if you look at the denominator, 2x minus 5, it doesn't factor either. So since nothing in the numerator factors and nothing in the denominator factors, that means nothing's going to cancel. So that whole denominator is my vertical asymptote. So I'm going to take that 2x minus 5 and set it equal to 0. I'll solve that equation, and that will give me my vertical asymptote. So I get 2x equals 5 and x equals 5 over 2. So typically it's pretty easy to graph a vertical asymptote. You just click the vertical asymptote tool and you can plot it where you want it. But here's the thing. It only works that easily if your vertical asymptote is an integer. So you can do like -1, -2, -3, -4, or 1, 2, 3, 4, anything like that. It's a little funky to plot your vertical asymptote when you have something like 5 over 2. So I'm going to teach you how to do that. Since the vertical asymptote is x equals 5 over 2, what you're actually going to do is plot a point at 5 over 2 comma 0. Now what you need to understand is this is not a point on the function. This is just a point we're using to properly graph the vertical asymptote. So I'm going to come in here and I'm going to type 5 over 2 comma 0. So see, it plotted a point there for me. Now I'm going to close that out and I'm going to click the vertical asymptote tool. And now it will allow me to draw a vertical asymptote through that point. So you'll notice when I clicked on it, the point went away. That's good. That's what I want it to do. Functions are never allowed to cross vertical asymptotes, so it shouldn't have any points on it. We were just using that point. Okay, so I'm going to cross this out because this is not a point on my function. It was just something that I was using to help me graph the vertical asymptote x equals 5 over 2. Okay, so now let's talk about the horizontal asymptote. So, because that's what I would want to graph next, horizontal asymptote. Now remember, horizontal asymptotes are not found like vertical asymptotes, where you just set the factor in the denominator that doesn't cancel equal to 0 and solve. Instead, horizontal asymptotes are found by rules, and those rules are based on the degree in the numerator in comparison to the degree in the denominator. So let's take a look at this. The numerator and denominator are both in standard form, meaning they're completely multiplied out. So the degree is just the highest power. So the degree in the numerator is 1 and the degree in the denominator is 1. So I'm going to say we have degree 1 over degree 1. So our rule states that if the degree in the numerator is equal to the degree in the denominator, which it is here, then the horizontal asymptote is just y equals, and we say it's the ratio of the leading coefficients, but the easiest way to say that is it's just the leading coefficient in the numerator over the leading coefficient in the denominator, which happens to be 5 and 2. So y equals 5 over 2. So again, we're going to use our little trick of plotting a point, but this time since it's at y equals 5 over 2, we're going to plot the point 0, comma 5 over 2. Okay, so I'm going to take my plot a point tool, and I'm going to plot 0, comma 5 over 2. So you can see it plotted a point there. I'm going to click my horizontal asymptote tool and click right on that point. Now notice that the point itself did not go away this time, but I need it to go away because I don't know that that's a point on the function. I was just using that to get my horizontal asymptote correct. So I'm just going to click that, make it go away. So again, let's see if it'll let me redo it. There's the point. You just click the eraser tool. You highlight this, but don't let the horizontal asymptote be yellow. You want to trace over it until just the point is yellow. Click on it and it will disappear. So once you have your horizontal asymptote and vertical asymptote plotted on your graph, no points on them right now. Now we're ready to move on to the next part, which is just to plot some points. So we're going to use our plot a point tool, and we are specifically told to plot 2 points on either side of the vertical asymptote. So see, here's our vertical asymptote. So we need 2 points to the left of the vertical asymptote and 2 points to the right of the vertical asymptote. So in order to do that, we're going to quickly just make a little XY chart. But before I do that, remember, this is not a point on the graph. We were just using that to accurately plot our horizontal asymptote y equals 5 over 2. So now we're ready to make a little XY chart. Oh, that's not very straight, but it'll do. This tablet is not the easiest thing to write on, but we'll live. So again, we need 2 points to the left of the vertical asymptote and 2 points to the right. You can pick any x values you want. So for the left side, I think I'm going to do 0 and -2. So I'll put those in order, -2 and 0. And for the right side, I think I'll do 4 and 6. Okay. So to get those correct points, I need to plug it into the calculator, which you'll need to, of course, use the TI-30 XII, which is required for this course. Okay, so let's go ahead and take -2 and plug it into the function. So I have 5 times -2 plus 1 over 2 times -2 minus 5. And I got 1. So 5 times -2 plus 1, 2 times -2 minus 5. Okay, so I plugged that in and got 1. Now I'm going to do it with 0. So 5 times 0, let's see, 5 times 0 plus 1 over 2 times 0 minus 5. Now for that one, I get -1/5. Okay. Now I'm going to type the same thing in with a 4. Okay, so 5 times 4 plus 1 over 2 times 4 minus 5, and I get 7. Okay. And now I'm going to plug in a 6. 5 times 6 plus 1 over 2 times 6 minus 5, and I get 31 over 7. So those are the 4 points that I need to plot on my graph, 2 to the left of the vertical asymptote and 2 to the right of the vertical asymptote. So we'll just use the plot a point tool. So it looks like we have -2, 1, plot a point, okay? And then we also have 0 and -1/5, plot a point. And then we have 4, 7, plot the point. And then we have 6 and 31 over 7, plot the point. So we've plotted all of the asymptotes and points they wanted us to plot. So now as a final step, all we have to do is click the graph a function button and it will draw curves through those points. So we're going to click check and there you go. That's all you have to do. All right, so let's look at one more. We're going to look at 18. I'm going to give myself some blank space on the whiteboard. Let's see what we got here. So it says graph the function, plot all necessary asymptotes, plot at least 4 points. We kind of did that last time because there were 2 on each side, but same thing. Okay, and also make sure there are 2 points on each side of the vertical asymptotes. So exact same directions for the most part that we had for the previous one. This is just a funkier looking rational, if you will. So this is 18. Get my pen back. Okay. All right, so we have n of x equals 3x squared minus 8x minus 3 over x squared plus 1. So again, let's start with that vertical asymptote. Now we do want to see if anything cancels, so let's consider the function as a whole. Let's back up for a minute. Okay, we have n of x equals 3x squared minus 8x minus 3. And that's over x squared plus 1. So the numerator does factor, the denominator does not. If it was the difference of squares, x squared minus 1, then it would factor. But it's x squared plus 1, so it doesn't factor. But the numerator factors. It factors into 3x plus 1 times x minus 3. Okay. And then we just said the denominator doesn't factor, so x squared plus 1. And remember, if you're not sure if your factors are correct, for example, if you weren't sure if 3x plus 1 times x minus 3 was the correct factorization of 3x squared minus 8x minus 3, all you have to do is FOIL it back out to check it. But anyway, nothing cancels. We factored, we can see that nothing cancels. So that means our entire denominator is a vertical asymptote. So we have x squared plus 1 equals 0. Or a better way for me to say that is our entire denominator would create a vertical asymptote. So we're going to try to solve this. So we'll subtract 1 from both sides. So we get x squared equals negative 1. And then we would square root both sides. But that's where we run into an issue. You know that we can't take the square root of a negative number. So that means when we're trying to solve for the vertical asymptote, we have no solution. So what does that tell us? It tells us that there is no vertical asymptote, which is interesting. We have no vertical asymptote to put on this graph, but I think we will have a horizontal asymptote. So let's go ahead and talk about that. Remember, again, horizontal asymptotes come from those rules. We have to compare the degree in the numerator to the degree in the denominator. So you want to look at this original form here, or here, if you will, where everything's multiplied out. That means that the numerator is in standard form and the denominator is in standard form, and therefore the degree is the highest power we see. So the degree in the numerator is 2, and the degree in the denominator is 2. So we have degree 2 over degree 2. And again, just like we talked about in number 17, when the degree in the numerator is equal to the degree in the denominator, then y is just leading coefficient over leading coefficient. So the leading coefficient in the numerator is 3. The leading coefficient in the denominator is an understood 1 right here. So we would say that the horizontal asymptote is y equals 3 over 1, or y equals 3. So we have no vertical asymptote to plot, but we do have a horizontal asymptote at y equals 3. So I'm going to click this horizontal asymptote tool, and I can actually go up to 3, right in between 4 and 2. So I'll plot it there. Okay, and then now we need at least 4 other points. So let's see. I think we can do an XY chart. I do think it would be best to go ahead and do our x-intercepts as 2 of our 4 points. So let's figure those out really quickly. The x-intercepts occur when y equals 0. So essentially that means you take the function itself and set it equal to 0. But when it comes to rational functions, that is more specifically the numerator set equal to 0. So we have 3x squared minus 8x minus 3 set equal to 0. We've actually already factored that because we factored it a minute ago to check to see if anything could cancel. So we know that this factors into 3x plus 1 times x minus 3 equals 0. Setting both of those equal to 0, we have 3x plus 1 equals 0 and x minus 3 equals 0. So that gives us 3x equals -1, or x equals -1/3, and x equals 3. So I can tell you that our first 2 points are -1/3, 0, and also 3, 0. So let's go ahead and plot those two. Okay, so -1/3, 0, plot point, and then also 3, 0, plot point. But we were told that we needed 4 points, and we only have 2 right now. So we just need to make an XY chart for 2 more points. Okay, so I'm going to drag this over a little bit, and we'll make an XY chart. And again, we only need 2 more points because we did our 2 x-intercepts. So I think that maybe I just want to pick something kind of easy. I think I'll do 1. I can see where 1 is. That would be an easy point. X value 1. And then also maybe x value -2. Okay. And remember, I'm just plugging those back into n of x. So I'm plugging 1 back into here and then -2 into there. I could also do 0, really, if I wanted to. That may be easiest, actually. So let me erase really quickly. I'm going to do 1 and 0. I think that would be the easiest. Okay, so if I plug in 1, you can do this on your calculator while I'm doing it on mine. I have 3 times 1 squared minus 8 times 1 minus 3 over 1 squared plus 1. And that gives me -4. So apparently at 1, the y value is -4. And then if I plug in 0, it's going to give me -3, but you can take a second to plug it in if you want to, just to check it. Yeah, -3. Okay, so those are the extra 2 points that I need. I apparently have a point at 1, -4. Okay, and then also at 0 and -3. Okay, so now that I have the 4 points that it asked me to plot, I just click the Graph a Function tool, and it draws that beautiful graph for me, and I click Check, and there you have it. Okay, so I hope that this video was helpful. I hope that it also gave you some instruction on 2 of the more difficult problems. But of course, just be sure to reach out to your instructor if you have any questions.